Hello friends, my name is Raman Share and my teammates are Nivita, Krishna, Soumya and Rishabh. We have completed our 6 weeks of internship provided by Leadingindia.ai and Bennett University. To solve any problem, we need to discuss or share our ideas, but the language understanding is the big gap. So for that, we will assign by the project named as a web-based model for neural machine translation under the guidance of Dr. Sunit Gupta. Neural machine translation is the application of deep learning in which massive amount of data set of translated sentence is used to train the model, which is capable for translating sentence of two languages. In this video, we will discuss about dataset, its description, and its preparation by some method. So it's over to Soumya.
Thanks Raman. Now I am going to give you brief description about dataset. Data is one of the most vital aspects of any research study. We have used dataset provided by manythings.org. We have used Hindi to English dataset, which is a text file and contains 2778 pairs of sentences. For using data in model, first data is prepared. Data is prepared by removing quotes, cleaning digits from source and target sentences, creating space between punctuation and words. Then we have to add a start and end token to each sentence. Then each sentence is padded to fit the maximum length criteria. The source and the target sentence are made into a word pair format. Then we convert the textual data into numeric form. It is done by transforming each word to one hot encoding vector. We then create the tokenizer and then apply tokenizer on source and target sentence. We have to split dataset into train and test. In our model, we have used 80% of data for training and 20% is used for testing. Now Rishabh will tell you about encoder and decoder.
Thanks, Soumya. Now I'm going to tell you about encoder and decoder. The MNT model consists of an encoder and decoder. The system first reads the sentence using the encoder to build a thought vector. A thought vector is a series of numbers that represents a meaning of sentence. The sentence, which outputs the translation of a sentence in the output language. The decoder, it processes the sentence vector to emits a translation. The encoder and the decoder are both RNN, recurrent neural networks. Thank you. Now Krishna Prabha will take over from here. Thank you.
Training and testing. The major drawback of the encoder-decoder model in sequence-to-sequence recurrent neural network is that it can only work on short sequences. This is the difficulty of the encoder model to memorize the long sequences and convert it into fixed length. Moreover, the decoder receives only one information, that is the last encoder hidden state. Now, this is where the concept of attention mechanism comes. The intuition about attention mechanism is that it can predict the next word by concentrating on the few relevant parts of the sequences rather than looking on the entire sequences. We are using a teacher forcing technique for faster training of our model. Teacher forcing technique is used for deciding the next input to be given to the decoder. Teacher forcing technique in which the target word is passed as the next input to the decoder. Encoder and decoder model with attention is trained using multiple epochs. We also calculated the time taken for each epochs and loss functions. Now Niveda will tell you something about conclusion session.
Myself Niveta, I would like to conclude the video by saying a few words about a project. Our neural machine translation model has the source and target language as English and Hindi respectively. The dataset used consists of number of translation pairs of both source and target language. The dataset was prepared by removing all the punctuation marks and other unnecessary numbers and symbols. This data was then fed into a typical encoder-decoder model, which is nothing but recurrent neural networks. This encoder-decoder model usually has problems with long sequences of text and hence attention mechanism was used. By training the model for a multiple number of epochs, finally the model was able to translate English sentences into Hindi translation successfully. The same neural machine translation model can be implemented for a different source and target language by changing the dataset translation pairs. The accuracy of the model can also be improved by increasing the size of the dataset and also by training the model for a more number of epochs. Thank you.